let's talk about arrays. We just made an array up on our recast.cpp. Okay. So back when you're doing C, you would have done an array just by declaring an array of 10 or 20 elements like that. And conceptually, that was basically creating a pointer to a first element, and you just did some pointer arithmetic to move along. Okay? Quite dangerous. Like, unless you know what you're really doing with pointers, that's quite dangerous. Okay? So in C++, we've got different containers to do this. Okay? We have vector and list, okay, for doing this dynamically. Okay? Vector and the list can grow and shrink by themselves. Okay? C++11 also has a new way of doing arrays that you should be using. Okay? You have this thing called standard array. You give it the type that it's storing and its size. Then you can assign elements into it, like that. Let's, again, our list initializations come back. And we can also copy an array, so B to A, just like doing that. Okay? So no need to do an array copy, it can just do it straight away, like that. Okay? A C++11 array knows its size, okay? And it supports what's called assignment, it supports random access iterators, it supports a whole lot of additional C++ style stuff that we'll come to in a few minutes when we talk about the STL. Okay? But both C and C++ style arrays need to know their size at compile time. Okay? So generally, go use a vector and a list, because a vector and a list at runtime can increase and decrease in size. Okay? So if we went back to our string code before, I've lost it now, but if we went back to our string code before and we were storing the names of people that we're entering in, we probably wouldn't do that as an array. That'd be a very dumb thing to do as an array. We'd probably do that as a vector. Create a vector to store the names in. Okay? Okay. So arrays themselves, particularly the C++11 style arrays, are data structures, they're types themselves, okay, that store a collection of objects of the same type. Okay? They're indexed, they hold a single type, they have a fixed size, they must be sized at compile time, they cannot hold references. You cannot have an array of references. Okay? And arrays generally cannot be copied or assigned. Now that changes in C++11. Okay? They can be copied in C++11. And it's better to use a vector. So let's talk about how do you iterate over an array. Okay? And we'll start in C and we'll gradually move to C++. Okay? How do you iterate over an array? So we've got an array of 10 ints. Okay? You might do this. Array I. For I equals 0, I less than 10, I plus plus. Okay? You might do it with some pointers. Okay, you can do that. And basically, that code up the top and that code at the bottom is the same code. Okay? Because int star is the same as this int square bracket. Okay, this is in C. Okay? So if we printed this array here, this two-dimensional array here, using C, or at least C style pointers, our code will look a bit like that. Okay? So we have a pointer to an array of 4. Okay? And then once we get outside our two-dimensional array, we've got the pointers doing that. Okay? It gets quite messy. Okay? Who can look at that code and immediately go, oh yeah, I understand what that's doing? Okay? Because I'll be honest, I can't. You know, you've got one person up the back who says they can. Yep. Okay. In C++, we could do this. We can do what's called a type alias. Okay? So this one back here, this line 10, was one of the more confusing lines. Okay? With a type alias, we can say we've got this thing called an int array of 4, okay, using int array int4, or type def int array 4, you can use one or the other, doesn't matter. Okay? And so that line 10, which is now line 13, you can substitute for int in there for this int array. Okay? Our code is actually still at this point quite confusing to read through and understand. Okay? But if you want to make your code a little bit easier to read, you might want to do that. Okay? Probably wouldn't recommend it, and you're still doing a whole lot of pointer math at this point you can stuff up with. Okay? So, this is about C++ starts to get fun. We can use what's called auto. We can make the compiler figure out what the type of something is automatically. Okay? And we actually commonly use auto with pointers and also with iterators. Okay? So this auto, from the rest of what goes on that line 10, it figures out that that needs to be some sort of int pointer to something that's sized +4. Okay? And the next line down, that line 11, for auto in line 10, for auto type it gets deduced, and for auto type in line 11 it gets deduced, are two different types. Okay? So auto is powerful, but can get confusing. You shouldn't just be using auto all the time. Okay, we can use iterators. Okay, this is probably the preferred way of doing it in C++, using iterators. Okay, so we still got auto over here. We don't have to use auto. We can work out what this is actually going to be. But we say standard.begin, and we pass in the object we want to iterate over, standard.end, and the end of that object. Okay, generally the end of an object is one past where it is in memory. Generally, it doesn't always mean that. Sometimes it can be the null pointer. Okay, and so we can do that with iterators, and that becomes a whole lot more clean and more easy to understand, and hopefully less buggy than where we started from over there. Okay, and the type checking that's going on here is hopefully a whole lot more strong because you're not dealing strictly with those raw pointers and stuff anymore. Okay. 4 different ways of doing the same thing. Again, if you want to go take a look at this later on, there's arrayprinting.cpp code. Okay, oops, where did it open up? Oh, there it is. Okay, so arrayprinting.cpp shows you those 4 different ways of being able to do it. Okay, I'll leave that for you to look at in your own time later on. Okay, but hopefully you can see the difference between doing the pointer math version, the type aliasing version, for auto version and for iterator version, that they all do the same thing, but use the one that's most clear to you. Okay. Now C++ 11 also introduces what's called a for each loop. And for each loop, if you've done this in Java as well, or there's some other programming languages which have for each loops, they say for and what you are storing the temporary value into, and for expression, which is normally for data type. And here's some stuff that you can go do in this for loop, okay? So here's a string, hello world. For each character in the string S, okay? Now we've decided to figure out C to be auto, okay? Convert that character to uppercase. And then print out the string, okay? And that's to auto, also notice that that auto here is a reference. If that auto wasn't a reference, this wouldn't print out. That's hello world, okay? And again, I've got that code sitting here, I think. Okay, yep, auto range. Okay, so here's the code. And so I can make that code, make auto range. Okay, .forward auto range. Okay, so that prints out hello world. If this isn't a reference at this point, if that's just like that, okay, so auto C, no reference. And I compile it, I run it, hello world is in lowercase, okay? So auto deduces the type, doesn't deduce if you want a reference or not. You have to decide if something should be a reference or not yourself, okay? So the auto and makes it a reference to the thing that you're automatically deducing the type out of.